You can see examples of the study design versus quality in the history of literature. We look at like smoking and cancer. All of that data comes from epidemiology. They're not randomized
Yeah,
controlled trials of smoking groups and non-smoking groups and then this link, but the numbers were, the data was so overwhelming. The
right.
association was so strong. We can make some pretty strong conclusions. You backtrack even further than that with scurvy, and vitamin C deficiency. The quote unquote research was awful, but it was so clear that like the effects were so strong. Then we can make some of those conclusions. And then on the flip side, you have this like really great randomized controlled study design. Everything is super spot on, but you have three subjects and you ask 27 questions with 27
Right.
outcomes, and so you like basically you're just looking anything and everything. So you can, your design can be strong but your methodology can be flawed, and
Yeah.
vice versa. And the what you the I love the point that you made, Mel, where you can even dive down to animal studies, because I think then the people are like, wow, you poo poo, oh, it's an animal study, no application in humans. And like, okay, fair, but the argument is efficacy and effectiveness. So we've got to understand mechanisms first. That's very helpful. So
Mhm.
in animal studies, that can help, and then we can transition that to laboratory human studies, hopefully getting the same type of response. And then what you mentioned is like effectiveness. Now we can try to take this to the real world and see how it's actually affecting outcomes in humans in their daily.
Right.
Yeah.
Yeah, and I think there's a couple things for each type of study that can help increase it or improve its weaknesses. So, for example, survey studies. I was just reading about someone posted, I think it was Tiago from RP, posted a really cool study showing a link between depression and inflammatory foods. And so, what you have here is a really strong link, right? People who are eating more inflammatory foods are more likely to be depressed. We have a similar problem that we often have with this kind of study, like cause effect, chicken egg. Is it the depression causing them to eat crappy? Or does eating crappy make them depressed? Or is there a gene that sits close to another gene, and one gene affects depression, one affects propensity to crave crappy food? So there's all kinds of conclusions you can draw, but a way that that kind of study can sort of improve upon its believability is, okay, can we, so to take smoking as an easier example to talk about, let's say that someone wanted to conclude that being healthy caused you to smoke, right? But if you do a study showing an increase in health when people quit smoking, a decrease in health when they start smoking, and a general association with bad health and smoking, then you have a lot more convincing of an argument there. It's hard to say, um, which is the chicken, which is the egg, and it's hard to reverse it given all three of those factors. So when you're looking at cohort or survey studies, those sort of directional tests of the data can be helpful. And then when you're looking at experimental studies, you want to see a large group, an in size that has enough power to get reasonable statistics. That's a little more difficult because you need to have sort of an understanding of statistics before you can analyze it. But I would say if the study's been published in the last 10 years, chances are no one let it slide through with horrible statistics in most cases. So larger n sizes tend to be better for experimental studies.
There's another big point that you threw out there. Not only, okay, so we've got, if we back up to the person who understands like 5% of what you're saying because they don't have this background, then we've got match the sample of the population. But also you mentioned alternative conclusions or alternative
Right,
hypotheses, aka how else could we have explained these results other than the
right,
way that the researchers explain them. And that is such an important thing because you don't need statistical background or you don't need to be a PhD
right,
to try to come up with different explanations. Like your example of depression and crappy diet. There's other, what socioeconomic demographic are these people coming
right,
from? What age group? How's
right.
all that stuff? Physical activity levels. So always ask yourself, how else can we explain these conclusions? And the less alternative hypotheses you can come up with, maybe the stronger the conclusion. That's kind of like a very
Right.
subjective thing, but this is really, really good.